Thank you for being there today. I hope you enjoy the day. You've enjoyed the keynote. I think it was eye-opening, very interesting. Maybe we will all be replaced at some point, or everyone will be able to program, and maybe it will be a good thing, because yes, about 30 million developers across the world against 8 billion human beings, maybe it's an issue for the future. So today, I'll share with you the lessons I've learned from building a generative AI playground, but I will come back to this in a few seconds. I would like to know more about you, so I will ask you a few questions. How many of you have already tried ChatGPT or a tool like ChatGPT, Perplexity AI? Okay, most of you. How many of you have used AI coding companion like GitHub Copilot, Amazon Q Developer, and so on? Yes. Okay. And now, a slightly different question. How many of you have already used foundation model to add generative AI capability to your application? Yeah, way less people. And that's what I will discuss today, how to use foundation model, or how does it work from a developer perspective. So by no means I'm an AI or machine learning practitioner. Well, it's not totally true. I have a PhD in handwriting recognition. I've defended my thesis about 15 years ago, so I have some knowledge in artificial intelligence, but since then I've stopped, because at that time in France, you didn't make a career with artificial intelligence, so I have to pay the bill, so I've switched to software engineering. So I'm a developer for 20 years. I know we are mainly in the Java community here today, but sorry, I'm a .NET developer. It will be fine. I won't discuss .NET or C# today. So last year, what happened? Last summer, my boss came to me and said, "Hey, François, yeah, my name is François Bouteruche. I work at AWS. I'm a senior developer advocate. So my job is to go and meet developers in Europe and Middle East Africa." And my boss asked me to take a look at generative AI and foundation model from a developer perspective, not from an AI ML practitioner perspective. We have folks in the team who are very knowledgeable on the deep details on how it works, how you can train a foundation model. I have no idea how you do this, and I'm fine with that. So the ask was, okay, from a developer perspective, how you use those foundation models to build an application. How does it work? So my boss asked me to deep dive on this, what I did. And most of the time, when I try to learn something new, I get my hands dirty. That's my way to learn. I need to start building something and hack, try. So most foundation models come with an API you can use to leverage them. So I've started to build a generative AI playground. Obviously, I work at AWS, so I'm using Amazon Web Service tooling and services. So the service I'm using is Amazon Bedrock, which is a foundation model services. Basically, it's a serverless services for a foundation model. You just have API. You say, hey, I want to use Anthropic Claude 3 model. I want to invoke this model, and you get an answer. You don't need to deploy this model. You can use Mistral. So I'll come back to this later, but that's what I've used. And today I want to share with you what I've learned as a developer from this experience. And to be sure that we are all at the same page, I will start with a few slides, and then I move to the application. I will show you the application I've built and discuss all the concepts inside this application to illustrate those concepts. So let's start with what is generative AI. So here we have two different flavors of foundation model and generative AI. On one side, on the left side, we have text-to-image modalities. So you enter text and it generates an image. And on the other side, you have text-to-text modality. You enter a text prompt, and it will create a text from there. The important part of this is you start with a prompt. You give some text. Here you give some text. Sometimes you can give an image, or you can give some audio. There are different foundation models. But you give an input, and it will create something new based on this input. That's why we call those foundation models, we call this generative AI, because it's the first time we have some AI model that generates something. We already have AI model to do some speech-to-text generation, for example, transform speech into text or transform text into speech. Those are also AI algorithms. We have AI algorithm to classify some text or to do some sentiment analysis. And something I want to stress out is that you can still use those AI algorithms. You don't need to use foundation model for everything, because what I've learned is this is expensive. Not you when you use it, but when you use foundation model, they require a lot of compute power to train or to run inference. So we are in a sustainable world nowadays, so be aware that there is a cost at using generative AI, so be careful, have a responsible usage of generative AI. They are very good if you just want to do some sentiment analysis. There are already good AI algorithms that do good sentiment analysis on text and that don't require to invoke a foundation model. So be mindful about this. Foundation models are really helpful. They bring a lot of value to the game, but you can still use existing algorithm. So let's take a look at what are language models. And here I'm not talking about large language models, just language model, because this is a road towards large language model. So back in the day when I was preparing my thesis, in the same office, I was working with another PhD student, and she was working on handwriting recognition too, but with language models. So basically, my job was to create algorithm to recognize character or words, and her job was to use language model to correct the mistake my algorithm was doing. So basically, if I was writing hello, and it could read Hilo, H-I-L-L-O, and she would use his language model to correct, say, hey, Hilo, it is not an English word, so let's fix this. The most likely word that you've written is hello, and we were already using at that time language model. But at that time, it was very small language model. And we could use them to do some word prediction at that time with simple word embedding. So you would have a word, and you would predict the next word based only on this word. So the model would have been trained on a large corpus of text, and it would compute the most likely next word based on this lazy word. So here, maybe lazy person. And then we improved this using memory, such as a recurrent neural network. And in this case, we could use several words. So here, fox jumps over the lazy. And in this case, it would predict rabbit, because it's most likely that a fox wants to hit the rabbit. So, and in 2017, a team released the Attention is All You Need white paper. And this white paper brings a brand new architecture for the transformer architecture for those language model. And I just want to highlight two two characteristics of this architecture. First, it leverages parallel computing and things like GPU to train. So it was able to make good use of this, and it was also capable of. It is also capable to process the input in parallels, so to grab more information. So I'm not a deep expert on this, but what I know is this is a game changer. This is, I would say, the discovery, invention, whatever you call it, that changed the game in terms of language model. And thanks to this, thanks to a transformer-based network, you could use the whole sentence and provide the whole sentence to the language model, and then it will predict that the next word is the dog, and tell you that it appears to be referring to the classic English pangram, the quick brown fox jumps over the lazy dog. So suddenly, the transformer-based network seems to have much more knowledge on the language. So let's take a look at how does text generation work. So basically, you give a prompt once upon a time, and you provide this prompt as an input to your large language model. You give this context, and as Eric told during the keynote, there is an iterative process here. So the large language model will predict the next word and use the whole context to predict again and again and again until it decides it has reached a point where the next likely token is the end of the text. And we'll say, hey, the text is over, or it will reach a limit you've set. I don't want you to generate more than 50 tokens. And remember, I'm not speaking about word, I'm speaking about token, because there is a translation between the word we know and the token. I would say the token is the numerical representation of our world, and this is what the large language model understands. So when we are there, we got the output. Most of a model provider call the completion, the results, and now we have the full text. Once upon a time, there was the mysterious magic castle, and here is the castle. So what are foundation models exactly? So you got this transformer architecture. You use some data and you use some GPU, you train the model, and you get a transformer model. Foundation model are basically the same, but with way more data and way more GPU to train. It doesn't take days to train those models. It takes weeks, it takes months. That's why only big tech nowadays, or funded startup or backed startup, have the capacity to train those models, because it requires a lot of money. Let's be clear, it requires a lot of money and access to a lot of data. And then, if you're doing this on text, you get large language model. If you do this, so there are other use like diffusion model for text image generation. So if you do this on image, you get some diffusion model. So out there, there are plenty of foundation model. You have the one of AI21 Labs, our own foundation model, the one of Anthropic, Cori, Meta, Mistral AI in Europe, Stability AI, of course, OpenAI. OpenAI is not there because those are the models supported by Amazon Bedrock. And each provider provides many different model, different generation, because they iterate. They also optimize their model for specific use case. Some models are very good at multi-language management, so you can speak to the model in French, in Dutch, in Spanish, in English. It's okay. Others are very good, only good at English, but they are very good on specific tasks like summarization. Others are very good as chat model to handle discussion. So we are at the very beginning of this era, and it goes very, very quick. So now I'd like to talk about the lesson I've learned, and to do this, I will quit the slide deck and go, if everything goes fine, to the app I've built. And I will illustrate this by using the application. So this is the foundation model playground I've built to learn. Just from a technology perspective, it is a .NET desktop application built with .NET MAUI and Blazor. So basically, it's like an Electron application. It's a web application running inside a desktop application. So I'm able to access to the web API, like the speech-to-text or text-to-speech API from the browser. I will come back to this later, but it's important to say. So here I can list the foundation model I have access to through Bedrock, my API. So this is not really important, just for you to know. And the first thing I've built in this application, the first time I get there is, okay, I want to build a playground to be able to send a text prompt to a foundation model. So here you can see I can select the different model. I will start with Titan Text because at that time, last summer, it was I had mainly access to Titan model. It was before Amazon Bedrock was in public preview. So I have early access. I had early access to the service, and the first thing I did is something probably like this. Once upon a time, and I just send this to the API, so to the foundation model. So here, imagine that each time I click on submit, I'm just making an API request to the service with the text as a parameter. That's it. I send the text, and I'm using the default inference parameter. I come back to this. And then I get, in the response there, in a faraway land, there lived a young woman named Emma. She was known for, and I don't know why, he has generated this morning. When I was trying, it was speaking. I try to avoid to giving a pronoun to a foundation model. Sometimes I say he, sometimes I say she, but I try to come back to it. It is not a human. It is a foundation model. Sometimes we anthropomorphize those foundation models, but we shouldn't. So this morning it was about a young boy. Now it's about a young woman. And so, okay, the next thing I did was to ask a follow-up question. So naively, I really did this. Naively, the first thing I did, the first time I was using those foundation model, is where does Emma live? And I realized that, okay, there are some guardrails, but more importantly, there is no context. A foundation model is stateless. And it was my first discovery. It may seem obvious nowadays, but foundation models are stateless. So we all know ChatGPT. So when we are already so used to ChatGPT that we think that foundation models are intelligent. They have no. Foundation models are stateless. They don't have any memories. ChatGPT looks smart because there are a whole team of smart developers, smart engineers that are building an amazing application on top of those foundation models. And they manage the memory. Same thing with if you are using Amazon Q Developer or Amazon Q Business, our own chat service. There is a whole engineering team building this intelligent application in front of the foundation model. So first thing, okay, we need to manage the memory. I will come back to this, but it was my first discovery. Then I realized that, okay, there are a few parameters to those foundation model. They are basically always roughly the same: the temperature, the top probability, the max token. Sometimes if we look at another provider, let's say Jurassic, no, same here. Yeah, Claude, you have an additional parameter, top K, but whether you use top P or top K. So let's deep dive on this. So the temperature is roughly the distribution of likelihood the model will consider amongst all the world. So the lower is the value, the more it will stick to highly likely words and next token. The more you get to close to 1, the more it will consider an unlikely token. So it's kind of adding fuzziness to the service. Top P is, okay, I consider a lot of unlikely token, but top P is among all those unlikely tokens, what is the percentage of those tokens I need to consider? So the more the value is close to 1, and the more unlikely token it will consider. So it has some impact on the inference latency. So the more it will consider token, the more it will take time to generate the text. But you may want to have some fuzziness, or you may want to have very deterministic, if we can say this, because it's not really deterministic. You may want to have very deterministic answer, or kind of deterministic. And the max token, it's basically you want to say, hey, don't generate more than 100 token, 500 token, or it depends on the model. Here again, it's a way to stop. So it will continue to generate until it considers that, okay, I've reached the end of the story or of the text I need to generate, or I've reached the max token. So it stops based on the first limit it reaches. So that's the first thing. So the next thing I've discovered is using Claude. I think it was with Claude. Not Claude V2, but Claude Instance. Is here I click on Submit, and I got an error. Prompt must start with human turn after an optional system prompt. So it means some foundation model have a prompt format. And I'm not speaking about prompt engineering here. I'm speaking about a prompt format. So what Claude and the first versions of Claude model is expecting is, so let's remove this, is this prompt format. So it has to start with human, and here I can add my prompt. And end with assistant. Because the Claude Instance foundation model has been optimized to understand this kind of prompt and to generate the text that completes this kind of prompt. So we'll get this. So, and here's the continuation of the story, and I get the story. So we can have very different prompt formats. So for each foundation model you want to use, let's say you want to use Llama 2, this is a very different prompt. And I think it's even more obvious what it is. They are special tokens, in fact. The S, the inst, are special tokens that allow the model to understand, okay, here I will take the user instruction, here I will generate the completion. So in this template, I can add a system prompt. So I'm a football fan, and let's make a bit of fun here. You are a Real Madrid fan, and let's ask the prompt, what do you think of the last game between Real Madrid and Barcelona? Okay. Oh man, that game was crazy. Real Madrid and Barcelona always bring their A game when they face off, but this last match was something special. The energy in the stadium was electric, and both teams played their hearts out. So basically, it's quite fair. It highlights that the game was really good, and both teams did a great job. And now let's change the system prompt. And let's say you are unfair. Oh my God, how could you even ask that? The last game between Real Madrid and Barcelona was a complete farce. The refereeing was a joke, a travesty. The refs were biased towards Barcelona. It was likely. Okay, so as you can see, what it generates is very different. So foundation model, they don't have any personality. You can give them a personality. You can decide what personality you want them to have. And here, it is using travesty as a word. I want to warn you about responsible AI. It's up to you. So there are some services like Amazon Bedrock guardrails that you can use so that it track the content of the answer and eventually filter whether your input, if someone tried to make your chat generate bad text, or it also filter out the output if it detects that it generates racism or things like this. It will filter out the output. So it's really important to understand that they are trained on a massive corpus of data that human beings have generated. They've tried to filter out those data and to remove the bad things, but there are still a lot of bias in the data. You may have seen those discussions about image generation, where when you ask for a man, you always have a white man, for example, at the very beginning. So they try to work around those bias, but it's up to you when you use those foundation models to be careful at what you are building and to make sure that your system is not biased. So something else that I want to show you. So you may have seen that it's quite long to generate. We are waiting, and we are waiting for an answer. Most foundation model providers support response streaming when you call their request with server-side event or WebSocket. It depends on the provider. So here I've checked the box response streaming, and I click on submit. And here you can see I receive the token as they come. So remember, I've told you that the foundation model was recursively generating the text. So what those response streaming option is doing is basically the foundation model, the API of the foundation model is just sending back the token as they are generated, while they are generated, so that you can receive them and provide a nice user experience. Here again, it's up to you to decide. If you are building an end-user application, a chatbot or something like this, yes, obviously you want to have something very interactive and show your user that you are generating text. If you are building agents that discuss between agents, because this is the next step of our application, it's basically AI agent discussing between AI agents without any human interaction. You can skip the response streaming option and just wait for the answer. There is no issue with this. So it's up to you to decide if you want to use response streaming. So if we look at Llama 3, they have a different prompt format. Mistral has a similar prompt format to Llama 2. So here again, it's up to you to take a look, because here, I could send this prompt to Mistral, and I will get an answer. The issue is that it won't be optimized. It just generates a whole text, and it's very unpredictable what will happen if you don't use the prompt format for which the model has been optimized. So if you want to take the best of the foundation model, really investigate the prompt format the foundation model is expecting. And obviously, foundation model provider try to improve the experience. So let's say for Claude, for example, yeah. So remember, so the prompt format is this one. And now they are providing what they call a messages API, where so if I do this with messages API checked, I won't get an error. It will work because they've changed their API. So now this new API doesn't expect a prompt as a text string. It expects an array of messages, and messages is a two-property object. The first property is role. So you say, hey, the role of this message is user or assistant. And the second property is text, is basically the prompt. So you send an array, an ordered array. The first message in the array should be a user message, and then you alternate between a user message and assistant message. So you can send back the whole conversation like this, and the API will convert this array of messages into the prompt format the foundation model expects. You don't have to care anymore about the prompt format, and all model providers are evolving towards this kind of API. Sometimes they call it messages API, sometimes they call it chat API. It depends on the model provider. So I told you that so we need to take care of the memory. So here I've just built a chat playground. So in this case, I can have a conversation, and my application is managing the memory and sending back the old prompt at every invocation. The important part here, all foundation models have a context window size, a fixed and limited context window size. At the very beginning, this context window was quite small. Nowadays, the latest, if you go with Gemini, they mention more than 1 million tokens. Anthropic Claude models are above 100,000 tokens, so you have room for giving a lot of text, a lot of context. But imagine you want to build an AI agent that knows you well, and remember all the conversation you had with this agent. At some point, you will reach the limit of the context window. You can't send back every conversation. So there are some techniques to manage this, like context compression, where you simply ask the foundation model to summarize the conversation and say, hey, here's the conversation, please summarize it, compress it, in a way you keep all the meaningful information you need, and it will generate a text. Sometimes it is not even a readable text for you, but the foundation, as Eric said, the foundation model is able to get the value of it, and then you can continue to have more information. And at some point, even with context compression, you don't have enough context window size. So you can use Retrieval Augmented Generation techniques, so the one Eric mentioned during the keynote. So basically, you put all this context, all of this conversation into a database, and you search back into your memory like we do as humans. I don't know for you, but personally, when I have a conversation with someone, I don't remember word by word this conversation. I just remember the general topic, the important information, but not the conversation word by word. So we can do exactly the same leveraging foundation model. And here again, the foundation model is not smart. We are building something smart with memory, with leveraging the foundation model. Okay, still have a few minutes. We can also mix and match different AI services. So here, I'm mixing speech to text, text to speech, and foundation model. Hello, Titan. How are you doing today?
Hello. How can I assist you today?
Okay, sorry, so my English accent is really bad. I'm French, sorry about that. So that's the kind of interaction you can build, mixing different AI services, having speech-to-text and text-to-speech recognition. You can also add image recognition. You can. That's how they build ChatGPT. They mix and match different AI model and AI services to build this complete experience. And you can do the same. Last thing I want to show you before to wrap up is agent. So now that's the next step. When you start to leverage your foundation model, you want to build agents. Agents are able to handle complex tasks. And here I've built an agent, so you can use different framework, generative AI framework to build your own agent, like LangChain, like semantic kernel, like Streamlit, like I forgot a name. Anyway, so you can build those frameworks here. I'm using, because I wanted to go fast, I'm using Amazon Bedrock Agent. So it's a managed service to easily build an agent. What I did is I've scrapped all AWS product pages and service pages, all those HTML pages, and I've stored them into an S3 bucket. And I've set up an agent that will use this to let me know the idea is, I'm a Java developer, I want to know more about IoT on AWS, and the agent will search among this knowledge to craft the best question. And why I'm scrapping the page into a S3 bucket? Because a foundation model has a cutoff date. So the foundation model doesn't know about everything we've released after its cutoff date. So what the service is doing is it's vectorizing all the text into embeddings, storing those embeddings into a vector database, so indexing all this content. And my Bedrock agents will start request this knowledge base about meaningful content to answer the question. So let's say I'm a C# developer, so I've already typed this. And so the sentence is, I'm a C# developer, and I'd like to learn more about compute service where I can run my .NET web app on AWS. So now the AI agent service is syncing, and I think this time we can really say that it is syncing in some way. In a few seconds, we should have an answer. It takes time because first it will run a first invocation to the model. Okay, that's it. With my prompt, the system prompt I've designed into the service, and it will ask the foundation model, okay, how should I answer this question? And the foundation model say, hey, to answer this question, I will first call the knowledge base and search for information about AWS compute services for .NET developers. And two, I will extract relevant information from the search results and summarize for the user. So there is a first invocation just to know, okay, how we should proceed to answer this question. And the foundation model say, hey, based on the knowledge base I have access to, all the information I have access to, the request of the user, this is how I will split the work. And then it run it invoke this knowledge base here, and it retrieve. So here we have a product page about AWS Fargate. It's stored in S3 and so on and so on. And if I go down, at the end, we have the final observation. At the end, based on the retrieve, it says, hey, did you know you can use Amazon EC2 Elastic Beanstalk? And it sends back this answer. So it's a multiple-step process to answer to my question, to go and search for data it doesn't have inside its own knowledge. Yeah, there is a question.
So is this an agent or is this for generation?
It's both. It's an agent because it splits the task in multiple steps to solve the problem, and one of these steps is to leverage retrieval augmented generation. Indeed. Agents often leverage RAG, Retrieval Augmented Generation, to do their work. Yeah, indeed. So, yeah, I have 2 minutes left, so that's it. Just want to wrap up the story. So, my key takeaway for you is we pretend foundation model to be smart, as we do, but we pretend. They don't pretend to be smart. We pretend they are smart. Intelligence and being smart is very vague. Before we thought animals were not smart. We were the only intelligent living on Earth. Nowadays, research shows that animals are intelligent. Foundation models have no memory. They are stateless. They may optimize for a specific prompt format, so do your research when you select one. They share common parameters and have their own, the temperature, the top percentage, and so on and so on. They all have these kind of parameters. You can build smart application by mixing different AI services and foundation model, and you can build smart application by creating AI agents that are specialized. We are the smart people in the room for now. Maybe it will change. But for now, we are still the smart people in the room. So feedback is a gift. So if you have the application installed, please leave me some feedback. It helped me to improve the presentation. If you don't have the application, you can scan this QR code. It is my own feedback survey, but I would prefer you to use the one from the conference. And if you want to go deep in the detail of the code, you can scan this QR code and you will navigate to a GitHub repository where you can find the source code of this application and get access to everything. Thank you for your attention, and if you have any question, feel free to ask.